Hello, this is Gregory Maxwell, and in this lesson we will talk about simplifying complex fractions. It's a continuation in our series on rational expressions, and this one will be about simplifying complex fractions. So let's talk a little bit about what that is. A complex fraction is a fraction whose numerator is or denominator or both contain fractions. So in this example I have here, we have 5x squared over y over 10x over y squared. So it's a fraction divided by a fraction. In this other example, we have arithmetic example. We have a sum of 2 plus half minus 1/3 divided by the quantity 3/4 plus 1/6. So that's a complex fraction. Now there's more than one way to simplify a complex fraction, but I'm going to focus in on one method. And it's simply by multiplying the numerator and denominator by the least common multiple of the denominators of all fractions present. That means we look at the least common multiple of the denominators of the numerator and the least common multiple of the denominators of the denominator fractions. And then we multiply the top and the bottom by that least common multiple. And remember, least common multiple of denominators is in short called an LCD, for least common denominator. It is shorthand for the least common multiple of the denominators. So let us take a quick look at that and see how we could go about doing that process. Let's take a look at these two examples here. And the process is relatively simple. We look at the numerator and we see that the denominator here is 3. There's a whole number, so that denominator is 1 and the denominator is 6. So what we need to do is find the least common multiple of the denominators of this fraction and this fraction, because the other denominators are 1. So least common multiple of the denominators, LCD, is 6, because that's the smallest number that is a multiple of both 3 and 6. Then I'm going to take my fraction, my complex fraction, and I am going to multiply the numerator and the denominator by the common denominator that we just found, which is 6. Now, since we're multiplying a sum or a difference, the distributive property applies. So the distributive property says if you multiply a sum or a difference by another number, you distribute that number to each part of the product of the expression. So 6 multiplied by 1 would be 6, and 6 multiplied by 1/3 will be 2. And that will ensure that the denominator will cancel, because the number we're multiplying by is a multiple of the denominator. So 6 multiplied by 5/6 is 5, and 6 multiplied by a -1 is -6. In multiplying the numerator and denominator by the common multiple of the denominators ensures that all denominators are cancelled, leaving only whole numbers to work with, which makes it a much simpler process. This now becomes 6 plus 2, which is 8, divided by 5 minus 6, which is -1. And that equals to -8. Now, there's another way to do this. I won't show it in this video, but I will just give a brief description. One way to do it is to combine these fractions as one fraction, combine the denominator as one fraction, and then treat this as a division of two fractions. And that will work out to be the same result. However, I chose to do it this way because I believe it's a much simpler approach. Let's move on to the next example here. The next example, 3q over p minus q, and q minus q over p. So as you can see here, the least common multiple of the denominators is p, because the only denominator we have in all the fractions, in the numerator part and the denominator part of the complex fraction, is the only denominator is p. So we're just going to multiply each part by p, and that will mean we'll distribute. And as a quick side note here, when you're doing these types of questions, it's important to write your letters and variables and numbers clearly so that there's no confusion. For example, you don't want to confuse a q with a 9, for example. So when we multiply, distribute the p to each fraction, we will end up with 3qp over p. Let me just write that out just to show what's going to happen there. 3qp over p minus qp, and then divided by q minus qp, or let's do qp minus qp over p. Now let's just remind ourselves that this means that the p is not allowed to be 0. We are not allowed to have a 0 for p, because then you'll be divided by 0, and that's not allowed. There's another restriction that is going to show up, but we'll meet that when we get there. The p's here will cancel, and also here. So that leaves us with 3q minus qp, and that's divided by qp minus q. Now I can factor this, so I'm going to factor the q in the numerator. So that is 3 minus p, and I'm going to factor the q in the denominator, and that means leaves p minus 1. And there we have an additional domain restriction, 2 other domain restrictions from here. P is not allowed to be 1, nor q is allowed to be 0, because those will cause problems. So q is not allowed to be 0, and p is not allowed to be 1. So we'll state those domain restrictions at the end of the process. So we end up with, oh, well, the q's cancel. Neglected to mention that. So we end up with 3 minus p over p minus 1, with the stipulation that p is not 0, p is not 1, and q is not 0. Let's try another one, or another 2. So for this question, for number 23, we look at the denominator here, the LCD. We see that there's an a. Then this one is a squared, so we're going to square this one so that both a squared and a can go into a squared, and both these are the same denominator. So we're just going to distribute, we're going to multiply the numerator and denominator of the complex fraction by the LCD, which is a squared. So I'm rewriting the expression, and then I am going to multiply the numerator of the expression by a squared and multiply the denominator of the expression by a squared. And I will distribute that to each term, and that will cause us to simplify the fraction so that the denominators will cancel. So when we do that, we get 2a squared over 2a, which would mean the a and the denominator will cancel. We'll show that in a minute. And we have 3a squared over 3 over a squared, and then we have that quantity is divided by 4a squared over a squared minus 9a squared over a squared. Now let's remind ourselves here that would mean a squared is not allowed to be 0, so that means a can't be 0 either. And we continue operating. Oh, let me just correct that a bit. So now that gives us the a squared will cancel one of the a's in the denominator, and the a squared here will cancel, leaving 2a plus 3 in the numerator. These a squares will cancel in a squared, and I made a little error here. This is not supposed to be a squared, that's just an a. So let's correct that right now. So there we have it. So one of the a's in the numerator there cancels with the a in the denominator. So our fraction becomes 2a plus 3 over 4 minus 9a. And as you see, the denominator here can't be 0, so we have to make sure that 4 minus 9a is not equal to 0. So that means a is not allowed to be equal to 4 over 9 if you solve for a. So then we have our restriction then. Our answer then is 2a plus 3 over 4 minus 9a, and with the stipulation that a is not 0 nor 4 over 9. Let's go on to the next example. Now this one looks a little bit more complicated, but in reality, if we remember our exponent rules, it is not that complicated. It's actually relatively easy to do. So let's go on and do that one. So with this question here, what we will do is we will rewrite the negative exponents as positive exponents by moving the term to the base to the denominator. So we have 1 over d squared minus 1 over c squared divided by 1 over c minus 1 over d. Then the least common multiple of the denominators, the LCD, would be c squared multiplied by d squared, because that's each term can go into those. So when we are now going to do the process, we have 1 over d squared minus 1 over c squared divided by 1 over c minus 1 over d. And at this point, you can tell here that c and d are neither of those are allowed to be 0. We'll write that down in a minute. And we're going to multiply by the least common multiple of the denominators, which is c squared times d squared. We're going to multiply the numerator and denominator. And in doing that, by the way, it's effectively multiplying by 1, because you're multiplying both the top and the bottom by the same number. So they would, in theory, cancel each other out if we didn't distribute. And let me just identify here that c is not allowed to be 0 and d is not allowed to be 0. And we'll see what else is there. I'll put that down at the bottom here. C not equal to 0, d not equal to 0. We'll revisit that in a minute. So when we distribute here, we get c squared d squared over d squared minus c squared d squared over c squared divided by c squared d squared over c minus c squared d squared over d. And now we can start canceling some stuff. The d squares here cancel, the c squares cancel, and then 1c cancels with that, and 1d cancels here. So let's see what we end up with as a result of this whole process. We have c squared minus d squared over c d squared minus c squared d. And we still remember that c is not allowed to be 0 and d is not allowed to be 0. We recognize that this can be factored, so we're going to do a little factoring just in case we can do a little bit more simplifying. That's the difference of squares. So we have c minus d times c plus d. That's what the numerator factors to be. Then the denominator, the common factor here, is cd, and that leaves d minus c inside the parentheses. So we have an additional condition. Apart from c not equal to 0 and d not equal to 0, we must also have the condition that c is not equal to d, because that would cause this thing to be 0. Additionally, remember that c minus d is the negative of d minus c. So I can rewrite this whole expression here. I can actually do a little cancellation actually. And I can say if I cancel c minus d with d minus c, I end up with a negative 1, because it's like dividing a number by its negative because of this property here. So that leaves us with this result: negative c plus d over cd. Or you could say c plus d over negative cd. stipulation that C is not equal to D, C is not equal to 0, and D is not equal to 0. Alright, we're going to go on to do some additional examples. And as usual, I recommend that you try this example before you see the answers that I give. So for this one here, we see there's a notice here that each term is a multiple of 3. So we're going to be able to cancel out 3, but let's not do that yet. Let's first identify our least common multiple of our denominators. So our least common multiple of our denominators, or LCD, is P minus 1 multiplied by P, because that's the denominator here and that's the denominator here. So that's our least common multiple of denominators. So our expression now becomes 3 plus 3 over P minus 1 over 3 minus 3 over P. All of that will be multiplied by the quantity P times P minus 1 in both the numerator and the denominator. And of course, as usual, it gets distributed to each term on each part on each side. And we also have to remember that would mean that P is not going to be allowed to be 0 and P is not going to be allowed to be 1, or as we would be able to do the simplification. So moving on here, we get 3 times P minus 1 plus 3 times P minus 1 over P minus 1. And then the denominator is 3 times P minus 1 minus 3 times P minus 1 over P. And now let's see if we can start canceling a few things. This cancels and this cancels, and that's what we have cancellation so far. Now let's proceed and see what result that gives us. So we are going to have, I'm going to distribute the 3p here, so we'll have 3p squared minus 3p plus 3p, that's this 3p here, and then divided by this 3p squared minus 3p minus, and I distribute this 3p plus 3, because I'm distributing this negative 3 into the parentheses here, and distributing this 3p here and this 3p here. Now, simplifying the numerator, we get, and as you can see, all of these have a max factor of 3, so we're going to factor out to 3 as well. So we have 3p squared is going to be the numerator, because these two guys, when you add them, you get 0. And then the denominator is 3p squared minus 6p plus 3. I can then factor out a 3, and I get p squared, 3 parentheses p squared minus 2p plus 1. And then the 3's cancel, and that leaves us with p squared over p squared minus 2p plus 1, which actually is a perfect square trinomial. If you factor that, you end up with p minus 1 squared. And remember our restriction that p is not allowed to be 0 or 1. That's the answer. That one took a little bit more work. You have to make sure you check all the time if you can factor. So we'll go on now to do another example. I would like you to pause the video, try this one on your own and see how it works out. And that will be our last example for this video. So in this case, or least common multiple for denominators, LCD. First denominator in the numerator part of the complex fraction is y plus 2. Next denominator is y minus 3, so I'll multiply that in. There's already a y minus 3 in the common denominator, and there's a y plus 2, so that's our least common multiple for denominators. So this now, we then point out that y is not allowed to be negative 2 nor 3, because then that would cause the denominators here to be 0. That's not allowed. We may end up adding more restrictions as we go along, but we have to be careful that we make sure we take note of those restrictions from now. So we have 1 over y plus 2 plus 4 over y minus 3, and that's divided by 2 over y minus 3 plus, minus 7 over y plus 2. And now we're going to multiply the numerator and the denominator of this fraction by the common denominator, which is y plus 2 times y minus 3. Y plus 2 multiplied by y minus 3, which we will then distribute. So we end up with y plus 2 times y minus 3 over y plus 2 plus 4 times y plus 2 multiplied by y minus 3 over y minus 3, which I'm putting those individual terms in parentheses. Then we have 2 times y plus 2 times y minus 3 over y minus 3 plus minus 7 times y plus 2 times y minus 3 over y plus 2. And now we can start canceling like terms, common factors. Cancel, 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 cancel. And I'm going to distribute the parentheses in a minute, but let's just write out what we have so far. We have y minus 3 plus 4 times y plus 2 divided by 2 times y plus 2 minus 7 times y minus 3. So we're going to do those distributions and combine like terms, simplify as much as possible, and then remember to put our domain restrictions, both the ones we've already selected and any new one that may show up. So we have that's equal to y minus 3, and let me just make sure there's no confusion there, plus 4y plus 8, because of distributing the 4, over 2y plus 4 minus 7y plus 21. Now we combine like terms, and we end up with y plus 4y is 5y, negative 3 plus 8 is 5, over 2y minus 5y is negative 5y, and 4 plus 21 is 25. As you can see, we can factor out a 5. Let me do it this way. 5 times y plus 1 over 5 times negative y plus 5. And the 5's cancel. And we end up with this result. Y plus 1 over 5 minus y, or negative y plus 5. And then the restrictions are that y is not allowed to be negative 2, 3, and now 5 because of this denominator. So let me put that down here just to make sure we're clear. So y is not allowed to be negative 2, 3, or 5. That's our answer. One way you can check if you have a correct result is to just plug in a number a couple of times to see if you get the right answer. For example, if we plug in 0, we should get 1 over 5. So when I plug in 0 here, I get 1/2 plus -4/3 in the numerator, and I can just do that on the calculator. 1/2 minus 4 over 3, and then I'm going to divide that by what I get, and I do the denominator. -2/3 minus 7/2, and that would give us the same as 1/2, 1/5, just as it would have here. And then we can try another number like plugging in 1 and see if you get the same result. So that's one way you can check, by plugging in numbers into the simplified expression and seeing if it gets the same answer when you plug it into the original expression. And that brings us to the end of this lesson. It's a short lesson, and it's related to the concept of simplifying rational expressions, multiplying, dividing, adding, and subtracting. Is all a part of the same unit. So I would recommend that you review the other videos and do additional practice on such places as Khan Academy. And of course, check OpenStax, OpenStax, openstax.org for the free open source textbook with practice exercises. That's all. Remember, keep practicing.